Unit 2 work and energy. Last video, molecular vibrations. Consider a diatomic molecule. Diatomic means in a particular molecule there will be two atoms. It consists of two atoms of masses m1 and m2 bound together in the molecule. And the energy of the molecule is very low, so that their separation is close to the equilibrium value. This can be represented by the energy diagram. Here the R0 is the equilibrium value of R, and this can be considered, this diatomic molecule system can be considered as two atoms connected by a spring of equilibrium length R0 and spring constant K. These two masses m1 and m2 bound together by a spring, and they are making vibrations. Spring is compressed and elongated. This is the spring. m1 and m2 are the masses attached. That is, the diatomic molecules having masses m1 and m2 are bound together. This R1 is the position vector of mass m1 and R2 that of mass m2. The equations of motion of the two systems. F is equal to kx m1 r1 2 dot. R1 2 dots. This is the symbol of d square r1 by dt square. If we are putting one dot, it will be dr1 by dt. Here there are two dots. It is an acceleration term. This m1 r1 2 dot is equal to k into r minus r0, and m2 r2 2 dot is equal to minus k r minus r0. This minus sign is that indicates that m1 and m2 are moving in the opposite directions. Here r is equal to r2 minus r1. This is taken from the figure. Then from equation 1 and equation 2, r1 2 dot, this m1 can be taken to the RHS. r1 2 dot is equal to k by m1 into r minus r0. Similarly, r2 dot is equal to minus k by m2 into r minus r0. Now we can subtract equation number 5 from equation 4. Equation 4 minus 5. Here r1 2 dot minus r2 dot, therefore this negative sign is taken here. r2 dot minus r1 2 dot is equal to minus k by k into r minus r0. This is constant. 1 by m1 plus 1 by m2. Here m1 m2 is the LCM. Therefore this term m1 m2 by m1 plus m2 is called the reduced mass of the system, denoted by mu. Therefore this is 1 by mu. It is r2 dot minus r1 dot 2 dot is equal to minus k by mu into r minus r0. From equation 2 we have r is equal to r2 minus r1, and r2 dot is equal to r2 2 dot minus r1 2 dot. And solving, we get r2 dot is equal to minus k by mu r. This is the equation similar to that of a simple harmonic motion. Simple harmonic motion equation we have s2 dot is equal to minus omega square x. Here r2 dot is equal to minus k by mu into r. And comparing these equations, we can have a conclusion that minus omega square is equal to minus k by mu. That is, omega is equal to root k by mu is the angular frequency of the molecule. Now, non-conservative force. A force is said to be non-conservative if the work done depends on the path taken for the movement. If path-dependent forces, non-conservative forces are path-dependent forces, or the work done along the closed path will not be zero. Non-conservative forces, for example, frictional forces. When a body is taken from A to B through the forward motion, if the path is having friction, it will lose some energy, and if it returns, this frictional force loss cannot be maintained. Therefore, total work done will not be equal to 0. This is a non-conservative force. Then general law of conservation of energy. That is, sum of all energies is a constant. For any physical system undergoing a process is called law of conservation of energy, and this is considered to be the law of nature itself. And power. Power is defined as the rate at which work is done, dW by dt, and its unit is watt. Thank you.